So I guess we can start. Hi everyone, thanks for coming. My name is Dmitry. I'm working on an Ironic project for quite a while, and quite a while is more than 5 years. And I'm going to present the project to you and talk about how it works, what recent achievements we've got, what our future plans are, because I know some people know Ironic from long ago and may not realize how much we've progressed in that. I'm going to talk about our new project and integrating Kubernetes with Ironic for bare metal provisioning, and let you know how to get involved if you want to. So let's talk a bit about Ironic. So first, short poll. Who here knows what Ironic is? Who here is using Ironic in production? Aha, okay. I have some work to do. Okay, Ironic. Why provision bare metal? Any cloud, no matter how fancy, have bare metal somewhere underneath it. It's probably no longer common knowledge because of how much clouds have progressed, but there is hardware there. If you're a hardware provider, if you provision hardware, if you are a cloud provider, if you want to build your own cloud, you have to deal with hardware. And for example, there are triple project, Kyobe projects, which help with provisioning OpenStack using Ironic on bare metal. There are probably more, but I know these two. Some people using bare metal instances, provide bare metal instances for their customers directly. Why? Databases like bare metal, putting containers on bare metal may make sense. Your application may require raw hardware access. Your application may want to make the most out of your hardware. The maximum performance, no noisy neighbors that can spoil fun when you're mining by bitcoins. Is it so hard? Spoiler, yes. What is the hardest point? From my experience, the different technologies, management technologies for hardware, we all know probably APMI. It has been around for a while, which is extremely widespread. Pretty well working, relatively, but lacks many modern features that a modern cloud could use, and I would mention a few of them later in the talk. There are featureful technologies like Redfish, which is a new thing in the hardware management, but it's not widespread, and there are vendor differences. When you start supporting many models, many vendors, it's surprisingly hard. Hacks and workarounds is a part of our life. My favorite example, I'm telling it to everyone, some BMCs, which is a management controller of the hardware essentially, lock up if you talk to them too often. Issue 3 requests in a second and you're done. It happens. We have workarounds for that. We enqueue all requests towards the same hardware to avoid that, because you never know. It's of course not something a vendor will tell you, like, hi, just be careful with it, it's fragile. UEFI support is quite interesting at times, and we have to support it because, as you probably might have heard, Intel is planning on getting rid of legacy boot. Probably Intel folks here can confirm and deny that. And when you support multiple architectures, it's also interesting, and UEFI is a big part of it because some architectures don't have legacy boot. And support for standard technologies is different. Like Pixie is not a thing everywhere. iPixie is not built for everything, and it may be interesting. And here we come to Ironic. Ironic is a service center, OpenStack umbrella, actually a whole family of services, libraries, and tools. Its characteristic features, it's fully API driven. So everything is done through API. You have API for a lot of actions. It's uniform across hardware to as big extent as possible, but it allows extensions in case of, for example, some operations that are just not uniform, unique for a vendor, for example. So you get uniform API, uniform base level, and you get extensions if you want to. We have a very wide support for standard technologies and emerging technologies. So IPMI, I mentioned it. Redfish, next big thing. It's a standard based on HTTP and JSON and infinitely extensible, which is actually a pain. Booting technologies like Pixie is probably known to everyone who ever tried to network boot a server. iPixie is older cousin, which is based on HTTP, is much more reliable. Virtual media is probably the most promising technology, even though not quite widespread and not as widespread as I would want it to. It's essentially connecting an ISO image on your HTTP server directly to the machine and just boot this. UEFI, we support it, which I know it's a big selling point for some operators that we do. We have an extensive vendor support, and it doesn't only mean we support vendors, we receive support from vendors. They run third-party CI, they propose patches, workarounds, drivers. This is the current list of companies we are working with, and I apologize if I forgot somebody because I was really busy when writing these slides. A big part of their support, as I mentioned, is a workaround for problems. And another my favorite example, I mentioned somebody today. When you issue an HTTP request, HTTP JSON request, post request against a server, and the documentation says empty body, what does it mean? So there are two correct answers. Literally empty body, content size 0, or empty dictionary because JSON. That's kind of real things we have to work around and hide from you. And that may be a selling feature as well. Oh, sorry. We support multiple architectures within the same cloud. For example, you can use different boot technologies for Power machine and for Intel machine and something like that. I definitely know that some people tried Power and some people tried ARM with Ironic quite successfully. Maybe more. Tell me. As I mentioned, Ironic is a set of projects. There are, of course, the Ironic, the main project, which contains bare metal API. We have a nice API reference published there. We have SDK support, our own Python Ironic client. We have the good support for Ironic in OpenStack SDK, which is a next generation Python SDK for the whole OpenStack. We have a recent support in Gopher Cloud, which was part of the Metal Cubed effort, actually, as I will tell you soon. We have a set of tools that can make your life easier when working with Ironic. Metalsmith, which is my pet project, that's why I mentioned it first. It's a Python library in CLI for easy access to Ironic, then through low-level Ironic client. Bifrost, some of you might have heard about this. It's a set of Ansible playbooks to provision Ironic itself and provision bare metal with Ironic. The Coyote project is an OpenStack installer that is based on Cola and Bifrost, by the way, and Ironic. Probably most of people who have heard about Ironic know that it can be used with OpenStack Compute, which is Nova, as a backend, as a hypervisor. So you can provide bare metal instances to your clients the same way you provide virtual instances to your clients, just distinguish on flavor level. And the Kubernetes integration, I'll talk about it a bit later. To present you the features of Ironic and overall how it works, I'll talk about the life cycle of a machine enrolled in Ironic. The high-level view is as follows. You create a node. A node is our abstraction for a machine. The first thing we do is verify access to its management controller. I know some people are interested in doing it. Okay, I want to use Ironic without access to management controller. It's possible. We have specially built drivers to do that. It's not that I recommend it to everyone, but if you're curious, it's possible. Next usually comes inspection, which is a process of figuring out what hardware is, what it's capable of, and even benchmarking if you want. There are optional plugins for benchmarking your hardware. That helps populating information that Ironic needs, or for example, if you use Nova, what Nova needs to schedule on Ironic. Cleaning is a bit interesting name for asserting the state of hardware before it gets ready for deployment. I'll talk about it. Then, of course, you add it to your fleet and deploy and deploy, clean, repeat. Rescue mode is the same as Nova Rescue. You can put a RAM disk on your hardware with SSH access and figure out something that, I don't know, you damaged your root partition. Serial console supported. Somebody asked me just recently. Graphical console is something we're planning on, but we need more hands and probably interested parties. Let's go step by step. Enrolling. As I said, it's a you have to populate the very basic information at least. It's a driver, which drivers probably you understand what it means. It's a way we communicate with hardware. It's combined of hardware type, which is, say, Dell iDRAC, and a set of hardware interfaces that define every aspect. For example, how we power it, how we do rescue, how we do deployment itself, how we do inspection. In the easiest case, you don't have to bother with it. You just say driver APMI, and we'll provide you with some good defaults. Inspection process, we support so-called in-band and out-of-band. Out-of-band essentially applies just talking to the BMC and says, okay, what do you have? You have NICs, CPUs, are you booting in UEFI mode, or booting in legacy mode? As quick, pretty reliable. Unfortunately, we don't implement it for the most generic APMI protocol, but vendor drivers usually support that. Redfish supports that. In-band inspection implies that you boot a RAM disk. So you configure your machine to boot from our technical RAM disk. It boots there, we populate information, post it back, and this can collect anything. That vendor independent, as long as you can boot it, you can do that. You can benchmark things. It's pluggable. We have a thing called introspection rules, which is a domain-specific language for operating on received data. So, for example, you can assign some properties of the machine based on how many GPUs it has, just as an example. It's in-band inspection is managed by a project called Ironic Inspector, which is part of our umbrella, but a separate service. And the same Ironic Inspector can do a thing which is discovering machines on the network based on Pixie. So you build your rack, you power them all on, and they start showing up with their details. And then you only have to figure out their management credentials and whether it's actually your server or it's somebody's laptop or iPhone. I don't know. You don't want to deploy an iPhone. We don't have a driver for that. Cleaning is a proof we are not very great at naming things because it's not only about, well, cleaning as you understand it. It definitely includes wiping hard drives or at least removing partitions from your hardware. It's better to start from a clean state. Then depending on the hardware type, you can do things like, okay, let's build some RAID. Configuring BIOS settings, updating firmware. With Redfish, we are getting more and more vendor support for these things. Yeah. And of course, when you do cleaning before you try to actually provision an instance, you verify that everything works, that you can boot it, because Pixie is sensitive to networking configuration, for example. Okay, the most interesting part, you come to deployment. If you're using Nova, it probably happens after your user did OpenStack server create and picked a flavor that assumes bare metal. Then Nova will allocate a node for you. If you're using Ironic standalone, and I want to emphasize it's possible to use Ironic without any other OpenStack components, there is a new allocation API, which allows you to pick nodes based on a few properties. For example, traits. If you're familiar with Nova, it's a similar concept applied to bare metal. We have traits for nodes. You can schedule in Nova using them. You can schedule with our standalone allocation API using them. And an interesting thing about traits is they're linked to a concept of deploy steps. So how it works, and it's a new thing in Ironic, you define a deploy template through Ironic API, which is a set of steps to run on a node each time this template is picked. And the name of deploy template is associated with the name of a trait. So when your user, for example, through Nova, picks a flavor that requires a trait, not only does it find a node that is suitable for this trait, it also can apply these actions from deploy template before deploying on it. So in the train release, we actually have support for several vendors for like building RAID on demand. So your flavor says, okay, build me RAID 2, for example. And it will happen not in advance, but it will happen during deployment, because if you have a deploy template that implies it. BIOS settings is another example that what you may want to do before deployment, like enabling virtualization extensions, for example. I mentioned booting a RAM disk. I also mentioned it possible to do through traditional PXE and iPXE technologies that have worked for a while. I'm very excited about virtual media, which is, as I said, a way to provide an ISO image or a floppy image to a machine through a secure connection to your BMC, not through insecure media as PXE is using DHCP and TFTP. So in theory, you can even do without DHCP, as I mentioned a bit later. We also have several options for deployment, for flashing the image itself, depending on your requirements. The most easy way and a traditional way Ironic used to connect the root disk through iSCSI from the RAM disk and just flash it from your control plane. That's pretty universal. It certainly has performance limitations, so we introduce another way for the RAM disk to pull HTTP image. And in some conditions, there is no in-memory caching. If you have a raw image, it can be streamed right to the device without in-memory caching. It's a relatively new feature as well. You might not have heard about it. And another rarely used feature of Ironic, we have an Ansible deploy interface, which can be used. The deployment happen orchestrated from the control plane using Ansible. And this option is infinitely customizable. You can write your playbooks, how to deploy. And I know some people actually use it, so it's pretty cool. Another thing that is easily overlooked, we have good integration with OpenStack networking for switch management. And that includes, for example, putting bare metals on the same VLANs your VMs exist on. That includes isolating your provisioning network where provisioning happens from your production networks where your customers live. That, of course, requires Neutron to have an appropriate MO2 driver for the switch, which is a pretty big limitation. There is a project called Networking Ansible, which tries to make it a bit easier by reusing the networking bits from Ansible for that. It's quite young and doesn't support many switches yet, but you can follow development. I'm pretty sure soon it will be a universal way to provision it. And when you're done with your instance, teardown comes and it follows with a short cleaning stage where again you can do some actions or at least wipe your partitions. Okay, how people are using Ironic or how we want people to be using Ironic. The most obvious thing, as I said, bare metal instances for the cloud. You can plug Ironic into Nova. Nowadays, the distinguishment is done through flavors. So bare metal resources are represented by a custom resource class in Nova. And you can have several resource classes, so you can have several sorts of bare metal presented to Nova. And on top of that, you can, as I mentioned, use traits for more precise placement and for deploy time actions. Switch management, I already mentioned. Cinder integration can be done through by combining iPXE with booting from iSCSI volumes. We really want to do the same for Ceph. We have some technical limitations, but we're getting there. Another use case is, of course, provisioning your infrastructure. It can be done with Nova as well. For example, Triplo uses Nova. It can be done standalone. For example, Kayobi is not using Nova, just Ironic. Maybe Neutron, I'm not sure. Bifrost can be easily used for this specific purpose. It's an installer of standalone Ironic combined with provisioner of bare metals using the installed Ironic. Ironic doesn't have hard dependencies on any OpenStack components, but supports several of them. Glance, Nova, Neutron, Cinder, among them. And you can mix and match. Just, for example, you can pick Ironic and Neutron, but not Nova. Why not? We're actively working on extending the standalone mode specifically. There's a specification proposed for a notion of ownership, and you can assign a node an owner, which, if you use Keystone, can be a Keystone project, to limit access to bare metals to this project. Because right now, Ironic API is usually used in an admin-only mode. We are working on that. There are some ideas about leasing nodes, where an owner can lease a node for some time to a person. There was some discussion with Blazor project on how to do that. We want to do switch management the same way with network in Ansible, but without Neutron as an option if you don't use Neutron. And some HPC folks are really interested in using kexec to avoid multiple reboots during provisioning. That has been a recurring idea for some time. We have some consideration about its stability on any hardware, but as a case for HPC people, it may be interesting. Edge is a big thing, and a lot of people are discussing it even here. As if you don't know, the idea behind edge computing is to bring computational resources closer to the consumer of these resources, which necessarily means distribution of your cloud between your central place and multiple places closer to your users. It of course poses a lot of challenges for bare metal management, especially around deployment process. Parts of that are, for example, using Redfish versus APMI, because APMI security is a bit interesting. You can Google it on YouTube. There are talk, I think, by Matthew Garrett about how bad APMI security. I'd highly recommend. Virtual Media avoids using Pixie with its unreliable TFTP protocol and allows transferring the image to a secure media, potentially, for example, transferring HTTP certificates, because you don't want to put your HTTP certificates on Pixie, on TFTP. And something we have a specification proposed but not implemented yet is an operation without DHCP, because necessary parameters can also be passed through virtual media, for example, IP, network, and everything. That can be really beneficial for the edge use case. By the way, if you have questions, you can interrupt me and just ask away, or hopefully have some time after that. And really, the last thing I wanted to showcase today is a new project, which is called, it's pronounced Metal Cubed, so in cube, essentially, because of conflict with another project name. And it joins Kubernetes and Ironic for bare metal provisioning. So, why bare metal? Probably pretty obvious. You don't have footprint of VMs. There's a thing called KubeVirt, which brings VM management on Kubernetes, which you don't want to run inside another VM, probably. There may be specific hardware access. I know some people interested in that. And here's how Metal Cubed was born. It's part lightweight Ironic container images. We build them specifically with low footprint, and that's standalone Ironic, no Nova, no Neutron, nothing. We've got custom resource definitions for Kubernetes for bare metal. We got a bare metal operator for hardware management. We got an actuator, I think it's called, for cluster API. And the idea behind all this is to have bare metal management cluster hosted, so not Kubernetes talking to something else. Bare metal management within Kubernetes as part of it. As I brought here, Kubernetes managing itself. That's the main idea behind this. I hope after the previous parts it should be obvious why Ironic, but just to repeat that, it's mature, beta tested. We in Red Hat have been using it for a long time as our installer and for customers as well. Fully API driven. And at the same time, there are enough low-level bits to build a solution on top of that. Vendor support, I mentioned, is very high. Pluggability in all parts of Ironic, also high. Go bindings in Gopher Cloud, of course, also a useful thing to have if you write things in Go. How it roughly works, I have two slides here, one with a picture, one with text, and didn't know which one to put first, so I probably just alternate between them. We have bare metal pods. We have a pod with bare metal operator and Ironic inside Kubernetes. It's integrated with cluster API operator. You're populating inventory, but creating a new type of resources, which is a bare metal host. And at this stage, enrolling, inspection, and cleaning happens. Then when you create a machine resource, we use the bare metal actuator finds an unused bare metal host, which inside of Kubernetes, Ironic is used for provisioning an image on the bare metal. And then the deployment of worker or master node continues. Yeah, again, that's how it looks. And the last but not the least, we're always looking for more input. We're looking not only like programmers, but people who are using Ironic who come and say, okay, we need this, we need that, it doesn't quite work. We got some awesome input from CERN folks who have more than 3,000 nodes on Ironic already. And we've had a few fixes from them on how to scale Ironic better. As to Ironic itself, here are documentation links. I specifically mentioned Bifrost separately, since it may be a good place to start with bare metal if you want to. Talk to us on IRC or write us a PMA on mailing list. And when it comes to Metal Cubed, again, there's documentation. There is a quick start script that can allow you to try it on a virtual environment. And there is a mailing list as well. I guess that's it. Does anybody has any questions?
Do you have a timeline for the DHCP-less provisioning with virtual media?
Timeline for so the question is about timeline for implementing DHCP-less provisioning, right? We really hope so. Train cycle is over. There's strong interest to finish it in Ussuri, and of course I cannot make any promises, but that's our target for now.
Do you have any timeline for the Ceph integration?
For Ceph integration, you mean with booting from volume? So. I haven't followed up with the Cinder team, but there was some work required on Cinder side to enable that. I need to check with Julia and with Cinder team as well. Again, I hope Ussuri, but we don't have anybody currently working on that, unlike the DHCP-less work, which has a person assigned. No more questions? Then thank you.